So, what are our trigonometry ratios? You guys remember? Sine, right? Cosine. Tangent. Okay. Yep, SOHCAHTOA, we're going to be using that too. Yeah, what does SOHCAHTOA help us figure out? Krakatoa? No, not Krakatoa. SOHCAHTOA. Okay, it's a mnemonic device. All right, I'll write that over here. Okay, so what are trig ratios, right? Well, these functions. These functions that relate angles, okay, in a right triangle maybe, right, or specifically in a right triangle, with a ratio of sides of that same right triangle, right? So it's a function that relates angles in a right triangle with a ratio of two sides in that right triangle, okay? And the SOHCAHTOA helps us remember which sides relate with, which trig ratio. So for example, sine, right, S in the SO, sine of an angle is equal to, O stands for opposite leg, and H stands for hypotenuse. Right, exactly right. Okay, I'll just abbreviate that HYP. Okay, cosine is the next one then for ka. Okay, what does the A stand for? Adjacent, and I'm going to say again, be specific here with the leg part, and then again H is for hypotenuse, and then tangent is equal to the opposite leg over the adjacent leg. Okay, exactly. All right, and so in a in a situation, let's just do a quick example here. We'll do some brief ones. So I'll draw a right triangle, and I'll call it I'll have like an angle A here. And I'll say that's a 3, 4, 5 Pythagorean triple there. Okay. And we can just do something like this. What would the ratio of the sides be here for the sine of angle A? What over what? Well, sine of an angle, right, is the opposite leg to that angle over the hypotenuse. So what's the opposite leg to angle A? 4. And what's the hypotenuse? 5. So 4 over 5 is what the sine of angle A would be. Do we know what angle A is? No, we don't. Okay, we could find it though. We won't worry about finding angles just yet. We're gonna solve sides today, but not angles. Eventually here. How about the cosine of angle A? What's that equal to? 3 over 5, yeah, adjacent over hypotenuse. And then how about the tangent of angle A? What's that equal to? What's opposite angle A? What? 4. And the adjacent leg? 3. Yeah, be careful. So the word, that's why I'm careful to specify the adjacent leg, right? Because technically there's two sides that are adjacent to angle A, both 5 and 3. We want to use the 3 there because that is the adjacent leg, okay? That's the adjacent leg, okay? I have tissues over here, Jeff, if you need some, okay? So, all right. That's great. But there's 3 other trig ratios that you maybe have never heard about before. All right, that is cosecant and secant and cotangent. Okay. These are merely the reciprocals of sine, cosine, and tangent. Okay? These are the reciprocals of sine, cosine, and tangent. That's why I put them in that order there. Okay? SEC. Oh, sorry, CSC is the first one. Yep. Cosecant, and then secant, and then cotangent. Yeah, you might not have learned those. They're not like necessary for like in geometry to teach those. Okay. Oh, okay. Well, there you go. But yeah, you don't have to. They're not like part of the curriculum. You don't have to teach those, show those. But I mean, they're just just the reciprocals of that. Okay. Okay. And if you want to be cute, you could say, okay, well, so in other words, so cosecant, let's see here, I guess I'll go down here. So cosecant of x would be equal to the reciprocal there. So it's hypotenuse over the opposite leg. Okay, secant would be hypotenuse over the adjacent leg. And then cotangent would be equal to the adjacent leg over the opposite leg. Okay, and if you want to have the mnemonic device for that, it would be Cosecant. Cosecant. Not very helpful. But there it is. Okay, you can just basically do your SOHCAHTOA and then just reciprocate stuff, you know. Yeah. Sine and cosecant are reciprocals. So sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Looks like apples almost there. I don't know. I can't really write the opposite leg, adjacent leg. Okay, you get the idea, right? Okay. Excuse me. So let's have you guys try one here. Okay. So identify all 6 now trig ratios for angle theta. Okay.
Why theta?
Why theta? I don't know. That just happens to be the Greek letter that we typically use when we're describing a generic angle. Okay. So there you go. I placed theta in there. All right. So we're going to just set up the ratios for all 6 trig functions here: sine, cosine, tangent, cosecant, secant, and cotangent. Yes, thank you. Yeah, that's good. Prepare, yes. Yeah, do it right now. Do it early. Are you like? You gotta eat some like bananas or kiwis or something too.
Yeah, on Friday I'm probably gonna bring like 2 or 3 bananas.
For marathon runners, they actually sell like salt tablets that you just like eat, and like there's extra salt and stuff like that. What's that? Salt helps you retain, I guess, the water. I think. Yeah. I think for whatever reason, yeah, it's a good question. I'm not sure exactly how it works biologically, but. No, it's not the energy. It's more like
it's electrolytes.
Yes.
You can't properly like your body can't properly work without a little bit of salt, and when you sweat, you lose salt.
Right.
So if you sweat a lot, like if it's very very hot, or if you're doing a lot of exercise, you can lose enough salt in your body so that you actually start to run into problems.
Right, the cramps and stuff. Quick check. Right at the beginning. What's this for? That's the master.
Ah.
Master. And then parallel perpendicular.
He was just doing this whole thing.
Yeah. And we're probably going to also have some standard formula.
Okay. Okay. Just how they manipulate.
We're also doing more. We're doing like 20 minutes of. Sam didn't do any word problems. I'm going to do some naked ones.
Okay. Gotcha. Okay. First, and then you go to the quick quiz kind of thing.
No.
Quick quiz
First. Because the idea of writing like I did and slope, but now I got to go over these.
Should be down by now.
Well, it's also something that's now middle steps
Yeah.
for what we're doing.
True.
So let's get that out.
You gotta be careful with like Gatorade because it doesn't seem like it, but a bottle of Gatorade has as much salt as a decent sized handful of fries.
Interesting.
For exactly that reason.
It's also a different kind of salt, though, too. It's not like
No, it also has potassium.
right.
Potassium chloride.
Yes.
Also, which is potassium chloride. In large doses, it can cause nerve damage, but it's actually sold as a salt substitute for people that can't have regular sodium for some reason.
Right. Yes. So. Okay. I think you can also make an explosive out of it. I saw it on some sort of like video or something like that, or a movie or
That's
something.
potassium chlorate.
Oh, chlorate. Okay.
Potassium chlorate is explosive. Chloride is.
No, it was like I forget what it was. It was like a show or movie. It was a movie. A guy always carried around. Oh, it was. Oh gosh, I can't remember what the name of it was. Anyway, it was on Netflix. Anywho, all right, back to this. It's I'm not gonna remember it now. So anyway, there are your ratios. Okay, pretty straightforward, right? We're just setting them up for right now. This right triangle is a special right triangle, right? Because the sides are in this ratio. Okay, if you don't recognize it, it's a 30, 60, 90 right triangle. We're going to be utilizing that in conjunction with our unit circle stuff to be able to like basically mental math, some trig ratios and things. All right. Some other things real quick I want to just show you too. Evaluating trig functions is something that we should be able to do, and the good news is sometimes we'll be able to use a calculator. Okay, sometimes we'll have to use a calculator. Okay, again, our end goal with the unit circle stuff is to be able to kind of like mental math some trig functions. Okay, so like eventually we want to be able to say sine of pi over 6 is going to be this, or cosine of 120 degrees is this. That's our end goal by Tuesday of next week. All right, but there's going to be some angles that we just we won't be able to do mentally. Okay, so now here's one that we will eventually be able to do mentally, but we'll go ahead and just say this one here. So for example, the sine of 135 degrees, right? Right now we don't know how to do that. So if we want to evaluate it, we got to go at our calculators. All right. Okay. If you go to type this into your calculator, okay, and you type in sine of 135, just like I did right here, okay, you're going to get this answer and it's wrong. Or if you get this answer, it's wrong. Well, Mr. Whitmire, why would my calculator lie to me? Well, it's because it's in the wrong mode. So if you press the mode button here, okay, and you look, you'll see that I currently have radians highlighted. And so what that did is when I did sine of 135, it gave me the sine of 135 radians, not degrees. And so in order to fix it, you have to go down here, highlight degree, hit enter, and now when I do sine of 135, it still gives me some crazy decimal, right? But at least now we can see, that is the right answer. We know it's the right answer there, okay? And I'll just approximate it here, 0.707. Okay? Likewise, if I want to do radians, okay, let's say I want to do like the cosine of like pi over 3. Okay, just as an example. I need to go back into my calculator here, hit the mode button, and go down to radians, and then I'll do cosine of pi over 3. Okay, which is 0.5, 1/2. Okay. And yeah, the pi button, if you don't know, second the caret below the clear button there. Okay. Exponential idea. Okay. So that's how you can use your calculator to evaluate trig functions. And again, this is the ratio. Now, obviously, 0.707 is not clearly a ratio there, but I mean, it's like the ratio simplified to a decimal. Okay. So if you make a right angle that has a 135-degree angle in it, and you do sine of that, then the opposite side divided by hypotenuse will be roughly 0.707. Okay, in measure, or the ratio would be that. Okay. And so then the last thing I want to be able to do here, just today we're going to cover, or more like review, I should say, is we're going to look at solving, okay, solving for missing sides of a right triangle. Okay, that's how we can kind of use these trig ratios. So let me just kind of squeeze that in over here. This is one kind of application of what we're doing here. Okay. Sorry about that. Okay. So let's say we wanted to solve for x here, right? We wanted to find x. Okay. Well, we have options, right? So for example, since it's a right triangle, we could use Pythagorean theorem, right? A squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. Will the Pythagorean theorem be helpful here in this situation? Okay, why not? What's the problem?
You're missing a leg.
We're missing two legs, right? If we had two of our sides, we can find that missing third side, no problem. But our Pythagorean theorem would have two unknowns in it, and you can't solve one equation with two unknowns. Okay, so we have to try something else. So we have angles as well given to us, so we're going to use trigonometry to relate angles and sides. Okay, so let's just pick here like the 30-degree angle. So x is what in relationship to that 30-degree angle? Is it opposite leg, adjacent leg, or the hypotenuse? Opposite leg, right? And then the 4, what's that? Hypotenuse. So what trig ratio would we want to use here that utilizes both opposite leg and hypotenuse? Sine. So we'll say sine, right, of 30 degrees would equal x over 4. Like that. But that's not the only option we had. We also could have used the 60-degree angle here, right? What is the x side in relation to 60 degrees? It's the adjacent leg, and then the 4 is still the hypotenuse. So what trig ratio uses adjacent and hypotenuse? Cosine. So alternatively, we could have said here cosine of 60 degrees equals x over 4 as well. Okay. In either case, to get the x by itself here, what do we have to do to both sides? Multiply by 4, right? So in this case, we'll have x equals 4 times the sine of 30. Or in this case, we'll have x equals 4 times the cosine of 60 degrees. Okay? And this kind of like brings up a property that you may or may not remember from geometry, where the sine of one angle is exactly the same as the cosine of the complement of that angle, right? 30 and 60 both add up to 90. So the sine of one angle is always going to equal the cosine of the complement. All right, so now we can type this into our calculator. 4 sine 30. Make sure you're in the right mode. Okay, we get 2. Or you can do 4 cosine 60. And again, we get 2, which we better get the same answer, right? If we're saying that they're going to both give us x. Bless you. Bless you again. So let me give you guys 2 to try here. So you guys try these 2. Okay. And again, just solve for x. Okay. So there's number 1. And number 2.
We always have a calculator for that.
You'll have a calculator when you need a calculator. For some of these, you won't need a calculator. Eventually. For right now, yes. For right now, yes. Okay, let's go ahead and try those 2. Find x in both situations. both situations.
Set up your ratios using SOHCAHTOA, right? Figure out if you've got like opposite side or adjacent leg or
Set up and solve here. I'll come around and get the rulers and the CDs here while I can take the ruler back here.
Thank you, sir. How many degrees of the angle?
Sorry?
How many degrees of the angle?
How many degrees in the angle?
On the first one?
45 degrees.
That's a 9, right?
Correct.
What's the angle of 35?
23.
23. 9.
I need to be writing more clearly, I think.
No, I'm just fine.
Well, that's true too. I know you have to replace it sometimes.
Okay. So we got, that is,
Hey, you like one more minute here? One more minute?
dang it.
Do you need a calculator, Jeff?
Never do these in time.
Do you need a calculator, Jeff?
No, I have one.
Okay.
Go too fast.
There's some nose button. You want how to degrees to radians or something like that? Nose
So that is the tangent, arrow down, leg, and leg.
Go forward to degree. Hit enter. Now, you hit the second one, quit, and then you go. Yo. No. So no, you went up. So you would use the inverse when you have. So that's good to remember that. You use it when the variable is your angle. When you're trying to figure out what the angle is. We're gonna do that later.
Oh, sorry.
That's okay. Okay. So what would you do? You want to get the x out of the denominator. So what would be a good idea to do? That would still have the x in the denominator.
Opposite over adjacent
So
is
multiple both sides by
tangent, right?
23. So you divide by x. How do you undo divide by x? Yeah, multiple sides x.
How do we set this up?
So it'll be x cosine 23 equals 9.
Opposite.
And then get the x by itself now. Divide both sides by.
Adjacent over.
There you go.
Which one's the adjacent? Which one's the opposite?
Adjacent is the leg that is next to the angle. That is part of the one of the angle's sides. The opposite leg is not a side of the angle.
But they're both touching. Which one of these? I mean, obviously that's the hypotenuse.
Sorry. This is a right angle. That's your 45 degrees. That's 9 degrees.
That's what I was getting wrong.
Yes.
I was about to say that was very confusing.
Yes. Yeah, we never use the 9-degree angle, right? We solve for sine and stuff.
That just didn't click. Okay, so now opposite. So that's x over 10 equals 45, right?
Equals us tangent of 45
Yeah, tangent of 45
is equal to x over 10. Yes.
Yeah.
Okay, Ethan, what's your setup for number 1?
Tangent of
So
45
I use tangent of
Tangent.
45 equals x over 10.
Yeah, tangent of 45 degrees equals x over 10.
Multiply the 10 over.
Yep.
So 10 tangent 45 equals x, and it comes out to
10. Right. Do we actually need to do...
tangent of 45 times 10.
Yes.
I
Do
got
we-
16.19.
Your mode is probably in radians, not in degrees. So hit the mode button and change it to degrees, and then try it again.
By the way, what?
Mode, and then go down to degrees and select degrees. Yeah.
You can also do it with the Pythagorean theorem because you know 45, 45.
Yeah. Okay. Use Pythagorean theorem. We can. What kind of triangle is this? Besides right, what else is it? Special right. 45, 45, 90. By its sides, though, how will we classify it?
We were like,
Isosceles, right? And so that means the two legs are going to be congruent. So you also could have done it that way too. But I'm glad you used your trig ratios. All right, let's go to May. May, were you able to solve number 2?
yeah.
Okay, what was your setup for number 2?
I did cosine 23,
9 over x. Great. Okay, and then how do you solve from here? What'd you do?
multiplied both sides by x.
Yeah. Yeah. So 9 over the cosine 23 is our precise answer, but of course, I'm assuming you typed that in your calculator and stuff.
Yeah.
What'd you get for your decimal?
8.28.
Approximately 9.7.
9.7 something?
Maybe wrong.
Okay. And there it is. Okay. So, that's that. Okay, sorry for the longer day today here. Okay, we did get a little delayed with the, I guess, the writing the unit circle stuff, but that happens.